All right, next we're going to talk about integration of trigonometric functions. So whenever we talk about integration, it's always good to think of differentiation in reverse. So let's go ahead and write out our derivatives of our 6 trigonometric function. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of secant of x is secant of x times tangent of x. The derivative of cotangent of x is negative cosecant squared x. And the derivative of cosecant of x is negative cosecant of x times cotangent of x. So when we write an integration of trigonometric functions, we actually use slightly different rules. So here, the integral of cosine of x. So we have to think cosine of x is the derivative. What was the original function? So cosine of x is the derivative of sine of x, which we can see here going backwards. And of course, we need our plus c for our general solution. So the indefinite integral of sine of x, so we say sine is the derivative of what function? So here, this was negative sine, would have been the derivative of cosine. So sine itself is going to be the derivative of negative cosine. And then we have plus c. Okay, so the indefinite integral of secant squared is just going to be tangent of x. The antiderivative of secant x tangent x is just going to be secant x plus c. The indefinite integral of cosecant squared. Okay, so again, we have that negative sort of thing happening here. So it's going to have to be negative cotangent x plus c. And here we have cosecant x times cotangent x. And the negative thing is happening again. So we get negative cosecant x plus c. Okay, so you can see you don't have to necessarily memorize all of these. Just think about the relationship between the derivative and the integral and how they're inverse operations or opposites. So now we can do problems involving trig functions. So here we have the integral of 2 sine x plus 3x squared. Now, when we do this, we can always separate these out. So we would get 2 sine x dx plus the integral of 3x squared dx. Okay, and you can actually go even further to take out that 2, because we know the constant will just get multiplied at the end. Okay, this one we don't need to necessarily because it's built into our power rule. Okay, so here we have the integral of sine x, okay, which is right here, sine x, and so its integral is negative cosine x. So we have 2 times negative cosine x, so we'll say negative 2 cosine x. Now we have a plus c, but we'll just wait to the end to add that on. And then the integral of 3x squared, so we get to practice our power rule again. So again, we want to add 1 to the 2, and then divide by that same number. And we can see here the 3's cancel out, so we actually get negative 2 cosine x plus x cubed, and then we're just going to write plus c at the end. So what happens is, if we added a constant from this one and a constant from this one, we still have a constant. So always just add that plus c. All right, for number 2, here we have cosecant squared. So the integral of cosecant squared is a negative cotangent. So I'll just write negative cotangent x. And then we have minus cosine x. So here we have regular cosine x, and its integral is sine x. So that negative is just going to continue on here. So we get minus sine x, and then plus c. Now what would be a method for checking these? Well, we could take the derivative here and see if we get this derivative right there. So let's try it. The derivative of negative cotangent, well, would be positive cosecant squared, which is right there. And the derivative of negative sine, well, would be negative cosine. And we can see negative cosine right here. So you can always test these out. Okay, I want you to go ahead and try number 3 on your own. See if you can find this integral. You can pause the video and come on back, check your work. All right, welcome back. So you can check your work here. You should have gotten theta squared minus theta cubed over 3 plus sine theta plus c. All right, in our next example, number 4, we have the indefinite integral of sine x over 1 minus sine squared dx. So here, you're going to want to notice the trig identity right down here at the bottom. So 1 minus sine squared actually equals cosine squared. So we definitely want to get rid of this division if we can. So let's see if rewriting this helps us. So it's one thing you'll notice, that we don't want this division when we're trying to find an indefinite integral. Okay, so now we have sine x over cosine squared x. Okay, well, none of this stuff talks about cosine squared x. So let's actually just rewrite this now as sine x over cosine x times cosine x. Okay, so now let's think about this. Since we have all multiplication, we can separate this out. And so I'm going to actually write this as sine x over cosine x times 1 over cosine x. So it's okay to separate out your fraction when you're multiplying. Okay. Now, sine x over cosine x is really just tan x, or tangent of x. And then 1 over cosine is really just secant. So we required a little bit of manipulation, but now that we have tan x secant x, you can see that that is right here. And so that we know the indefinite integral is going to be secant x plus c. Okay, so our whole goal is when you see this integral right here, we need to rewrite it so that it looks like some combination of these right here. So you're going to have to use your trig identities and then your reciprocal identities and all that other stuff so that you can try to get it to look like one of these so that we can actually take the integral. Okay, so let's go ahead and try the next one. And I want you to give number 5 and 6 a try on your own and see if you can't manipulate these so that they look like these and find your integral. So go ahead and pause the video, come on back when you're done. Alright, welcome back. Go ahead and take a look at the transformations that I did here and check and see that you get the correct derivative in both of these cases. Alright, so that's been integration of trigonometric functions.